So let's sketch the graph of a system of inequalities in two variables. We first sketch the graph of each individual inequality and then find the region that is common to every graph in the system. This region represents the solution set of the system, so where it's double shaded. For a system of linear inequalities, it is also helpful to find the vertices of the solution region. So we do need to figure those out, and we can do that graphically, but sometimes we can't, and so we have to solve the system. So let's sketch the graph of the solution set of the system of inequalities. Then we're going to label the vertices of the region. So let's do that first. So let's graph each of these. X minus y is less than 2. So we can rewrite that in slope-intercept form. So this is negative y is less than negative x plus 2, or divide by negative 1, so therefore we flip the inequality. Y is greater than x minus 2. So let's graph it, minus 2. And then the slope is 1. And then we know that it's a dashed line because it's greater than. And then greater than is above the line. So I can test 0. It is above the line. So let's shade that in. So we know that this is where we are here. Then let's graph x is greater than negative 2. X is greater than negative 2, so negative 2 is here. Again, it's a dashed line here. And then greater than negative 2, so that's going to shade to the right of it, right? 0, if we test 0, 0, 0 is greater than negative 2. So therefore, we know we're going to shade to the right of it. So I'm going to shade everything over here. And then I'm not going to shade to below that other purple line. I'm not going to shade here because that's not going to be my solution region, right? It's not going to be double shaded. So now we're going to do y is less than 3. Y is a horizontal line at 3, and that's less than or equal to, so it's a solid line. Then less than, so it's going to be below. If I plug in 0, 0 is less than or equal to 3. That is true. So then I'm going to shade down here. So notice this is the triple shaded region right here where I shaded. That is the solution region. So everything, if I plug anything in within those points, then that is the solution of the system. So we need to label the vertices. We could solve by solving the system, but we can also just read it. So that's always really nice as well. So they're all open circle. So here, this is negative 2, positive 3. And this point here is 5, 3. And down here, this is negative 2, negative 4. So it's really nice to be able to do that, and you can read that. But if you couldn't find it, like if it was a fraction or if you don't know where it is, you can always solve for it. So let's solve this system. So you set it equal to 0. Taking pairs of equations, solving the system of equation here. So let's do x minus y equals 2 and x equals negative 2. So then we're just going to substitute. So negative 2 minus y equals 2. Negative y equals 4, or y equals negative 4. So between those intersect at negative 2, negative 4, and that is true. So notice this is where it intersects. Then we do the next one here. So x minus y equals 2 and y equals 3. So x minus 3 equals 2 to substitute, plus 3. So x equals 5, and then we know that y equals 3, and that's where this is here. Then the last point, we could do these two. Well, you know that's going to be x is negative 2, y is 3, and that is it here. Okay, so that's how you would solve it. And then later on, as you see more complicated problems, if you can find where they intersect, that's always helpful. And then if you know the slope, you can find the rest of the line by just using slope. So try this example here. Sketch the graph of the solution set of the system of inequalities and then label the vertices of the region. So the solution region here is in the blue right in here. And then it's easy to read the vertices, so I just went ahead and labeled them. Of course, you could solve the system, and I think we know how to do that. So let's try another example. Sketch the graph of the solution set of the system of inequalities. So we have a quadratic here. X squared minus y is less than or equal to 1. And so let's solve for y. So I have negative y is less than or equal to negative x squared plus 1, or y is greater than or equal to x squared minus 1. So it's here, and it's equal to, so therefore it's solid. And then greater than, so let's put a dot in here, 0 greater than or equal to negative 1, that's true. So therefore I know I'm going to have to shade everything inside here. Okay, so I'm going to shade everything inside. And then let's do the next one. We have negative x plus y is less than or equal to 1. Let me do that in a different color. So let's do y is less than or equal to x plus 1. So here, and then the slope. It's really nice because it hits those perfect points there, so I don't need to figure out what the intersections are. And then less than or equal to, so let's just check 0 here. Is 0 less than or equal to 1? And that's true. So less than is here in this point, and so we can shade that all in. And so that's going to be our solution set is in here. And then let's label the vertices. That one was easy to find. Of course, you could plug it in solve for it as well. But this is 2, 3. And over here, x is negative 1, 0. And down here, that is 0, negative 1. So we can plug this in, if we can solve to find the intersection. So let me just show you how to do that. So let's solve this one. So x squared minus y less or equal to 1. So just set it equal to 1. And then negative x plus y is less than or equal to 1 or equal to 1. So I'm going to substitute for y. So let's add x to both sides. So y equals 1 plus x. So x squared minus 1 plus x equals 1. Or x squared minus x minus 1 equals 1. Subtract 1 from both sides. So this ends up being x squared minus x minus 2 equals 0. So then we factor x minus 2, x plus 1 equals 0. So we test x equals 2 and x equals negative 1. So if you plug it in, it's nicer to plug into the linear equation. So negative 2 plus y less than or equal to 1 or equal to 1. We're just trying to solve where they intersect, so equal to 1. So add 2. So therefore y equals 3. So we're at 2, 3. And look, that's where we hit right here. If we plug in x is negative 1, then we have negative 1 plus y equals 1. So 1 plus y equals 1. Subtract 1. Y equals 0. So therefore the intersection is negative 1, 0 right here, right? Oh, this is the vertex I labeled. Not necessary. So that's not an intersection. Okay. So go ahead and try this example here. Sketch the graph of the solution set of the system of inequalities. Just remember this is a sideways parabola, and so hopefully that'll help you out. Okay, if you tried this out, this is the parabola that you should have gotten, and then the line right here as well. And then I went ahead and plugged it in and solved in order to find the intersections of 1, 1 and 4, negative 2.